So, what about mm, arrhythmias? We start with atrial flutter. Atrial flutter and atrial fibrillation are two pathologies with the same pathophysiological mechanism, the reentry loop formation. It's the pathological loop, here we can see it, pathological loop of reentry. What does it mean? One electric impulse that is generated in sinus node, sinoatrial node, goes not directly to AV node, but goes several times through atriums. As a result, one electric impulse um, irritate atriums several times and induct several contractions of atriums. If this loop is large, we have a lot of we have several contractions from one electric impulse due to one electric impulse. In this case, each passing of the electric impulse will lead to one contraction of atriums. As in this case, we have three contractions of atriums, and fourth one is simultaneous to contraction of ventricles. Yeah, three atrial contractions and one ventricular contraction. It's the atrial flutter when the rate of atrium contractions up to 200, 300 beats contractions per minute. In case of atrial fibrillation, we have several loops of reentry of this, or this loop is smaller. With in this case, one electric impulse will lead to multiple contractions of atriums. Multiple contractions of atriums. And what are ECG criteria for atrial flutter? At first, we don't have P wave. I think it's understandable because uh, there is no normal contraction of atriums. There is abnormal scheme of contraction of right and left atriums, and on ECG we don't have P wave. We have flutter waves. Flutter waves. What about regularity? There are two variants of atrial flutter, regular one and irregular one. Two forms. It depends on RR interval. Next moment. Next ECG criteria. QRS complex. I repeat that if the patient has no pathology of ventricles, and in case of atrial flutter there is no pathology of ventricles, QRS complex will be normal. In case of atrial flutter, we don't have changes of shape, duration, or something like this of QRS complex. That's why next criteria is the presence of common QRS complex. It's an example of atrial flutter. We don't have P waves on this side, on this lead, for example, V5, you see these atrial flutter waves. 1, 2, for third one, we have ventricular contraction. Next pathology is atrial fibrillation. As you see, in case of atrial fibrillation, we have a lot of reentry loops, yeah, and each loop will lead to separate contraction of some parts of atriums. As a result, one electric impulse from sinus node will lead to multiple contractions in atriums. And as a result, we don't have separated contractions of all atriums. We have contractions of separate muscle fibers of atrial myocardium. On ECG, we have a lot of small waves that are called F waves that reflect contraction of separated muscle fibers. And of course, P wave is absent because there is no normal contraction of atriums. It's the first ECG criteria, the absence of P wave. The second ECG criteria is the presence of F waves, but modern devices have automated algorithm of noise reduction, and these F waves can be removed from ECG recording. That's why this criteria, presence of P wave, is not the obligate for modern devices. And next ECG criteria, irregular rhythm. You see RR intervals are not equal. I think you see it. And the third criteria, or fourth one, if we see F waves, is the common QRS complex. I repeat, if the patient has no pathology of ventricles, and in case of atrial flutter there is no pathology of ventricles, QRS complex will be normal, as in this case. It's an example of ECG with atrial flutter. We have no P waves here in each lead, yeah, we don't have it. We have irregular rhythm, for example, short RR interval, long, long, shorter, 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 long interval, irregular rhythm. And QRS complex is common. Another variant of real ECG with atrial flutter. Irregular rhythm, absence of P wave before each QRS complex, and common normal QRS complex. We administered some medicamental defibrillation for this patient, and that's the result. After the medicamental, how's it called? Restoration of sinus rhythm is called defibrillation, medicamental defibrillation, restoration of sinus rhythm. In this case, we have sinus rhythm, we see P waves before each QRS complex. We have regular rhythm, yeah, and we can calculate heart rate. It's about 20, 22. As I know, this speed of recording is 25. That's why we should multiply this our interval 24 by 0.04. It's about 0.89, and heart rate is about 70 beats per minute. These are all criteria of restoration of sinus rhythm. Another variant of atrial fibrillation in combination with another pathology. In this case, we don't have P wave. We don't have it. The rhythm is irregular, but QRS complex is deformed due to another pathology, conductive abnormality also, in addition to atrial fibrillation. Next pathology, extrasystole or premature contraction. It's the same. We have two variants, supraventricular extrasystole and ventricular one. At first, we speak about supraventricular extrasystole. What does it mean? We have focus of extrasystolic activity inside left atrium, right atrium, or AV node. All of these localizations are supraventricular. Theoretically, it's not so important in which part of conductive system or myocardium this focus is present, because there is no difference in clinical picture, clinical manifestation, and treatment of, for example, right-sided, right atrial extrasystal or left-sided. The same clinical manifestation and the same treatment. That's why, in general, it's called supraventricular extrasystal or supraventricular premature contraction. ECG criteria. We hear prolonged recording of second standard lead. We see normal complexes, normal complex. Then we have deformed P wave, normal QRS. Then normal complex, normal, another one. The first criteria is the absence of P wave or presence of pathological P wave. In this case, shape of P wave is another one. P wave is changed. It's the first ECG criteria. Second one, RR interval before extrasystal is another as common one. In this case, it's shorter. Third criteria, QRS complex is the same as non-extrasystolic one, the shape. Yeah, shape is the same. This one and this one. And fourth one, what about compensatory pause? In this case, we have incomplete compensatory pause. What does it mean? The RR interval between two normal QRS complexes, two normal R waves, is less than two normal RR intervals. What does it mean? The duration of this normal RR interval is about 10, 20, 29 millimeters or 29 small boxes. Normally, we have 29 millimeters here. Here we should have normal QRS complex here, and then second RR interval will be here. So this QRS complex present earlier as normal, and complete compensatory pause mean that the RR interval between these complexes should be two normal RR intervals. In this case, it's shorter. It's called non-incomplete compensatory pause. It was the fourth criteria of supraventricular extrasystal. Next pathology, ventricular extrasystal. We have focus of electric activity inside ventricles. It can be inside left ventricle, it can be inside right ventricle, it can be interventricular septum. It's not important for us, because as for supraventricular extrasystals, there is no difference in clinical picture. There is no difference in treatment of right ventricular extrasystal or left ventricular one. Of course, based on ECG, we can determine is it right-sided or left-sided one, but it's not significant for us as doctors, as clinicians. Before I will tell you about ECG criteria, we should discuss some terminology. We have single extrasystoles. It's for supraventricular extrasystole also the same. Single extrasystole when we have normal complexes before and after extrasystolic one. We have monomorphic extrasystoles when we have the same shape of extrasystoles inside one lead. It's so-called monomorphic. We have polymorphic, as in this case, we have one shape of extrasystole, the same shape, and another one. And another one. It means that we have, in this case, in uppercase, we have only one focus of extrasystolic activity. In case of polymorphic extrasystole, we have several focuses of electric activity of the heart. For patient, of course, it's better to have monomorphic extrasystole. It's an example of single monomorphic extrasystole. Oh, it's a polymorphic. Single polymorphic extrasystole, upper one. It's an example of couplet, when we have two extrasystoles one by one. It's couplet of monomorphic extrasystole. If we have three or more extrasystoles one by one, it's called grouped extrasystole. Group extrasystole. What about these examples? If we have some regularity of extrasystole, if we have normal, complex, extrasystolic one, normal, extrasystolic, normal, extrasystolic, it's called bigeminy when each second complex is extrasystolic one. It's the bigeminy. We have trigeminy when each third QRS complex is extrasystolic one. Trigeminy. We have quadrigeminy, pentageminy, etc. Criteria of ventricular extrasystoles. So, on this case, for example, second standard lead. Yeah, we have normal complex. We have extrasystole. First criteria is the absence of P wave. Second criteria, deformation and widening of QRS complex. You see it's wider than normal, of course, that's normal, and deformed. In this case, we have bigeminy, extrasystolia, normal complex, extrasystolic one, normal, extrasystolic, and up to the end. Each second complex is extrasystolic one. It's called ventricular bigeminy. It's polymorphic one because we have several shapes of QRS complex. This one, the same, another variant, and the third variant of ventricular extrasystole. It's the polymorphic frequent ventricular extrasystolia bigeminy type. On this ECG, you see another variant of ventricular extrasystole. It's the also bigeminy, but monomorphic because each second complex is extrasystolic one, but the shape of QRS complexes is the same. What about electric axis of the heart in this case? We use normal QRS complexes, not extrasystolic one. Only extrasystolic complexes should be excluded from analyzing.